Welcome, and thank you for standing by. All participants will be in a listen-only mode until the question and answer session of today's conference call. At that time, please press star 1 on your touch-tone phone to ask your question. Please unmute your line and state your name clearly so that I may announce you. Today's call is being recorded. If anyone has any objections, you may disconnect at this time. I would like to introduce your host for today's call, Mr. David Lamm. Sir, you may begin.
Thank you, and welcome, ladies and gentlemen, to the last in the Mississippi River Basin Healthy Watershed Initiative webinar series. And today's topic is managing cover crops for nutrient management, a farmer's perspective. And you're really in for a treat. I think today's presenter, Dave Brandt, is going to just stimulate your thought and just make you wonder why you haven't seen more of what he does being accomplished in your own local communities there. Well, let me go over a couple things before we get started with Dave's presentation. As with all of the Mississippi River Basin Initiative watershed webinars or any of the webinars we do here from the tech centers, they're all recorded. Generally, you should receive an announcement like you're seeing before, and for this one or for future ones where it makes it simple for you to just click on and join the webinar in progress. If you're interested in obtaining Certified Crop Advisor CEU credits, hopefully you know how to download the information. You just click on the little handout icon up in the corner, and you fill them out, and you send them to Dr. Holly Kirkendall at the bottom there. Make sure you put your name, your CCA number, and sign it, and send or fax the information, email it to her, and she will see to do that. And just for your interest, we get about 10% of the participants do get CCA credits, and we're trying to get credits for those who watch the replay. That takes a little more effort on our part and a little more willingness on the CCA group to be accommodating to our needs there. Questions, as the operator mentions, you can go through her at the end of the presentation by simply hitting star 1 if you want to offer an audio question, or if you hit the Q&A button, again, that's at the top of your screen, you can type in a question, and I'll read the question to Dave, and he'll give you the response that he seems appropriate, and I think that'll take care of that. So with that in mind, let me jump to Dave's presentation, and I just want to introduce Dave Brandt, who farms southeast of Columbus, Ohio, approximately 900 acres of corn, bean, and wheat, and he will tell you that more about his operation. I've had the privilege to be on his farm about 2 weeks ago, or about 3 weeks ago. He being a private individual, hosted a cover crop field day. 2 days we had about 70 NRCS employees there one day, and the next day was for farmers, and they had about 130, 140. He's telling me a little bit in our pre-conference chat here. He's had over 800 people visit his farm to look at whatever that big thing he's holding in his hand, and I'm going to let Dave explain that in detail. So, Dave, you go ahead and take it over, and let's hear what you have to say.
Well, thanks, Dave. And first, this is a cover shot of some of the radishes that we are growing. A little bit of background, and that's probably some of the slides I'll show first, is some of the background of where we started. Began no-tilling in 1972 with an OAC planter, learned how to do it, and worked with Chevron Chemical Company with their representatives, and have learned a lot ever since. The reason we started no-tilling was we farm the kind of soils that erodes very easily. Most of our ground is on highly erodible ground, as you can see in the picture. And this is just some shots of some conventional ground, and this is the reason we started. This is some real erosion that we have. This is, again, after corn planting time, we'll have some real erosion come on, and you can see how it runs down the corn rows. And we decided in the early 70s that we had to do better in this in order to maintain and become a profitable farmer. We have some wind erosion also on the flat ground, and when we started no-tilling in 1972, they said we were losing about 55 tons of soil per acre. At present, we're losing less than 500 pounds of soil over an acre on our total operation. All the farms that we farm today are no-till. Presently, we have about 55 or 60% of the ground under continuous covers with cover crops growing to supply nutrients to our corn crop, corn and bean crop. Like I said, we started with an AC planter, and just so some of you people don't know what they were because they're hard to find them now, but they were an antiquated planter, and it took about 4 horsepower to pull them, as you can see. Messed up somewhere. Back on. Sorry about that. We also did a lot of pasture renovations, and I threw this shot in here just to show you how rolly the farms that we farm in our area in Ohio. We did a lot of pasture renovation in the 70s and in the 80s. We operated a few hundred herd Charolais cow to calf finish operation, and we also had a few hundred sows spare to finish. And we didn't have time, my wife and I, to do all the ground preparation to plant corn and soybeans. We began in the early 70s, 78, we started with rye because we were losing some yield after corn after soybeans or corn after corn, and we figured we had to do something with cover crops to make it work, so we began working with rye. Rye is still in our rotation, and we have learned to use it quite diligently to grow soybeans and increase the yields. Here we're planting soybeans and corn fodder and also rye. This is what it looks like probably the last of May around our farm that we're planting when we're planting soybeans. This is our new planter, new tractor the last 2 years. This planter is equipped with GPS and variable rate technology that we can do variable rate seedings and also variable rate fertilization. This was rye that was broadcast into standing corn fodder at the rate of about 50 pounds of rye and 50 pounds of potash sowed on Thanksgiving Day the year before. And you can see it got about 18 to 20 inches tall and a reasonable stand that I would like to see rye like this because the sunlight will get down and the air will get around it, and our tough clay soils will tend to dry out a lot better when the rye is thinner. If we have some tough weather and don't get it planted, rye can come out of control, and this is, here I am out standing in the field trying to figure out what to do with it, But we just started in and started planting. The nice thing about the rye is when you're done planting in the field and you're going out the gate, if it's not all laying flat or knocked over, you missed some and you could go back and correct that. Rye this tall will tend to grow out about an inch of rainfall a day, and we can be planting 1 or 2 days sooner than our conventional neighbors can if we have rye in our operation. Here's our new planter again working out, and you can see how the rye, it lays it down. When the rye is in head like this and the planter lays it over, we don't use any herbicide on it, and it will just kind of wilt away and die because it's been crimped by the planter. And in this shot, we have made some rye haylage. In the front, we took the rye off and made some haylage. We had more than we needed, so the rye got taller, and we're in there planting soybeans. When we harvested the beans last fall, where we had taken the rye off, the beans made 54, and where the rye is still standing, where the planter and tractor is, it made 62. So at that time, we figured we didn't need to worry about how tall the rye was. It was still a benefit in our operation to get decent yields. And you can also see the round bales that we've taken off on a wagon. So we're doing about 3 things all at once here to try to get done. And this was on May the 27th. Just another shot of the planter working in the rye. We killed this a little early because one of the farms has got a lot of drouthy soils on it. and it was pretty dry for a couple of weeks, so we killed it earlier, and now we're planting into it. Most of all of our covers we plant while it's still green, and then kill the cover crop after we're done with the plantings part of the operation. This is wheat. We don't use much wheat as a cover crop, mainly because it's a little tough to kill. Here we got a pretty decent job on it, but you can see it's a little different color, and wheat tends to hold the sunlight away from the ground because you get it a little too thick, and it's really tough to get that ground warmed up enough to plant the corn or the beans in at an early stage, and this would have been on the 12th of May here. And this is just a shot of the soybeans after the rye. With no herbicide on, you can see that the planters rolled it down. In the upper right-hand corner, there's a little bit of weed pressure that we went in and straightened out, but 90% of the field did not have any herbicide on it where we had planted these beans. For our corn operation, we like to use legume crops that grow a lot of nitrogen. On our upper slopes, that's 15 to 18 to 20%, we plant hairy vetch. Hairy vetch will stay green all winter, and it'll grow back in the spring, and it'll supply about 190 to 210 pounds of nitrogen to the next year's corn crop. And this happened to be an April 26th picture of our vetch. Here I am just showing you how nice it is to plant into. We don't have any trouble with the vetch wrapping too bad on the chaves and the disc or anything. We do have a little bit you can see on the marker arm that wraps on there, but we are able to grow about 11 or 12,000 pounds of green organic matter, and when this dries out and decomposes in the soil, it will raise our organic matter in the soil about 0.5% a year, so we can increase our organic matters. We've went from 0.5% organic on our home farm to about a 5.2 in a number of years. Again, just another shot of the vetch after planting. Roundup and 2,4-D is the herbicide that we use. If there's not any grasses, we usually just use 2,4-D, but if we have some grass problems that's springing through or some volunteer wheat, we'll put Roundup in it to take it out. And this is on about an 18% slope, and the only problem you have with the vetch is it becomes a little slippery on those high slopes, and you have to watch when you turn the planter on the real steep slopes or it'll shove you down the hill. This is a picture of the vetch roots, and in the center you can see the nitrogen being formed by the nodules, and it is slow release throughout the growing season. These nodules are as big as your thumb and decompose throughout the summer and supplies all the nitrogen that we need for our corn crop, and our average yields are in the 170s to 200 bushel per year in the last few years. Again, there's the planter in the vetch, and when the planter runs the vetch over like this and packs it down, it will die, and we do not need to use a herbicide. A picture of the seed slot and the seed, you can see the corn seed there. You can see that the thatch is about 4 inches thick. You can also see the wheat stubble from the wheat that was in the year before. All the cover crops that we'll show here will be after wheat. We do not bale the straw, so all the organic matter's there, and with this legume, our carbon to nitrogen ratio becomes more equal, and we get really good response from our corn. You can also see the fibrous root system around the seed, and that ground is fluffy, and it's real easy to close the slot with the press wheels that we have on the planter. We use no row cleaners or no spider closing wheels or any other additional attachments, just a fluted holder in the front and a set of rubber press wheels on our corn planter. Our standby cover for most of our ground that's less than 10% slope is Austrian winter pea. These peas are sowed into wheat stubble. We cut our wheat about 12 to 13 inches tall, This is sowed with a drill at about 30 pounds to the acre. As you see here in the picture, that the winter peas will have a lot of root system to it. They tend to have a primary tap root. The main tap root's probably as big as a pencil. And then we have nodulation at the 2-inch level, the 3 to 5-inch level, and clear at the bottom of the shovel profile, which is 9 inches deep. We have some there that will come available to the corn plant when it's setting and doing the test weight and improving the yield of the corn there. So we have nitrogen that breaks down throughout the growing season of the next year. Again, just some more shots of the nodulation. On the right-hand corner of the picture, you can see some earthworms. And those earthworms are our chisel plow and disc and those kind of things, because we do no tillage on our ground anymore. And this was an 18-inch spade that we were using, and this just shows you the root mass from the winter peas and how the nodulation is formed. And when you take a shovelful of dirt out, it looks like you spread urea all the way through the profile. And that's the best way I can explain it to you without being on the farm to show it to you. And then this is what it looks like come planting time in May. It freezes off during the winter. It's not a thatch that sticks tight to the ground. It's probably 2 or 3 inches above the ground because the straw is holding it up. And you can see the holes in it there, and the air gets underneath it. The soil dries out and it warms up. We're able to plant about 2 or 3 days before our conventional farmers can, because the soil will hold us up and it's warmer. We use a lot of sludge on some of our farms. It's close to the city. We're about 12 miles from the capital of Ohio, which is Columbus. And this happened to be a field that put some sludge on. We get it free. We don't have to pay for it. And then we sow oats on it. The oats will get from 12 to 20 inches tall. Sometimes the oats may even go to head. We will mow the oats off and make bales hay or round bales out of it to feed the cow-calf herd. The problem we have with sludge application, sometimes they don't get it uniform. And you can see by the picture, you can see where they're double and triple overlapping with some of the green strips in the oats. This is a shot of crimson clover that we're putting in after corn. This happened to be after corn silage. The crimson clover on our farm, we began using it again the last 2 years, and it has really showed us a lot. And it looks like it's going to produce and will produce about 130 or 40 pounds of nitrogen. It'll get about 2.5, 3 inches tall before our winter sets in, and then it regrows in the spring and makes a nice thatch to plant into to plant corn. This happened to be chickling vetch. This was our first time to use a vetch like this. Was really excited about what I saw, but this was 30 days after planting. It went to bloom, then it made seed pods, and then we had no nitrogen left in the soil. So this was our first attempt with chickling vetch, and will be our last, because we do not like to have our cover crops go to seed or even make bloom during planting. And this happened to be a September 30th picture, and we still have probably 45 days more of growth that we could use a legume crop to keep growing. It did have a nice root system. I was impressed with that, and it really loosened the soil. You can see the structure of the soil on the shovel, and you can see what these roots are doing for our ground. And this is just another shot of our earthworms, and that is my primary tillage tool there. And when we do a earthworm count, we'll end up with 30 to 50 earthworms per square meter on our farm. We began 5 years ago with cabbage and turnips and radishes. We saw this in a meeting I went to 5 years ago, got really excited about what we saw. My wife was with me, and she says, "You're probably going to stop somewhere and buy them and bring them home," and I did. So we tried them by themselves. we found out that there's a lot of difference in radishes. We found that the radishes we bought were called forage radishes. They ended up being about 12 or 14 inches tall, maybe 2 foot tall, but they didn't put any roots down. The cattle really liked them. The deer really liked them. We could just have deer all over the place. And so we began looking at other radishes to see what we could do. We also use a lot of buckwheat. We like buckwheat because it's a shallow-rooted plant. It'll have lots of roots in the top 2 or 3 inches, and it will enhance the phosphorus uptake, or the buckwheat will bring up some phosphorus from the subsoil and make it more available to our corn plant. Annual ryegrass, we've worked with it. Our biggest problem with our annual ryegrass is we do not kill any of the cover crops till planting time. Usually the ryegrass is 12 to 14 inches tall. It's going into dormancy at that point, and then we cannot get it killed. So we're looking at new varieties now that will not grow quite as rapid in the spring, and maybe we'll have better success with herbicides when we go to beans or corn in an annual ryegrass situation. Phacelia is a new plant that we're trying. The bees really like it. It's a plant that has a tremendous root system, and it comes out of France, and the things we've found out about that this last year or 2 years, it's very hard to establish. It's a real fine seed. It looks like the pepper you would shake out of your pepper shaker on your table, and if you get it over a 1/4 inch deep, it just will not grow. This was our newest investment, our new white planter. It's an 8-row 30 with 7 splitters. Our planter can be used for planting corn, soybeans, cover crop, and wheat in 15-inch rows. We are able to utilize this planter about 5 months out of the year, and has really made us a lot of money. It's probably been the only piece of equipment we've used that's made us a lot of money versus other tools that we use. And what we learned to do was, you can see here that we have winter peas in 1 row, which we're using a soybean plate for, and in the 2nd row back is the tillage radish, and it is a sugar beet plate, or a small milo plate will do the same, and it's a 30-cell plate, and our soybean plate's a 120-cell plate, and when we put those together, that just seemed to give us the perfect spacing for our peas and radishes. We are able to simulate the seeds so that we can plant our radishes 4.5 inches apart, and our peas are 2.5 to 3 inches apart, like a corn stalk. We also can use the same plates to plant Sunn hemp. This is a new plant that we're trying in our area. This year our corn is 18 inches taller where we had this plot in that we have corn on now, and the corn has 2 more rows of kernels. So we're impressed with what we're seeing with our Sunn hemp. The Sunn hemp will die or freeze off when the air temperature gets to about 34 degrees, but the radishes keep growing. Both help each other as a complement to enhance the growth. Here's the Sunn hemp after it got cold in the fall, and our radishes here ended up being about a 1/2 inch bigger in diameter and about 3 inches deeper in the soil versus where we had them with peas and radishes. And here it is when the snow was on. You can also see that some of the radishes have jumped out of the ground. The reason that is they've either hit a compacted air layer or they've hit a rock, and our radishes seem to grow to the height of the compaction, and then it'll push the primary root through the compacted area and keep right on growing. This is Fava bean. We're on our farm. We try a lot of different things to see if they'll work, and this was again another plant that we tried 1 year, and probably will never try this again because we just did not see much response from anything that we did with it in the plots that we had planted. Here's the Fava beans and the radishes. The radishes are on 30-inch rows, and the fava beans are on 30-inch rows, but they're 15 inches apart. And this is the primary. We have about 412 acres presently planted this way, and these are winter peas and radishes, tillage radishes, 15-inch rows. This is what we like to see in the fall. This was a September picture. These radishes were planted the last week of July, and what we see is that our radishes are bigger when they're planted with peas. The peas develop more nitrogen because I believe the radishes are pulling the nodulation of the nitrogen away from the pea, so it produces more nitrogen, and in turn the radish gets bigger. And this is like 6 weeks of growth after planting, and you can see how well things are getting along. This is one I skipped, and this is a shot of the soils on our farm. This is a Cardington soils. It should be yellow. This is after 40 years of no-till, probably after 6 years of different types of covers. And we talk about covers. The fields only receive cover 1 out of 3 years because we're on a corn, bean, wheat rotation. And we went from a 0.5% organic matter in this field to a 5.5 and a soil density of 1.43, which is comparable to the wood that borders this field on the right-hand side. Our wood lots has the same soil density as our field does presently. Oops, wrong way. This is what the radishes look like in March. They have frozen off during the winter. The snow has melted. We had several calls from the fire department because when these decomposed after the first snow, it smells like a natural gas leak, and that may be a problem. So we've learned to notify the fire department where we're planting them. I think the best thing that we've learned about these is that they do have an odor in the spring, and I think if the economy ever turns around where building starts again, we'll be able to curb development by growing these things so I can keep farming, rather than building the houses. But you can see the carcasses of the radish, and it looks like the radish row has had a strip tiller pulled in it. This is some of the soils. The earthworms tend to really like the radishes as they decompose. They seem to crawl right into that cavity where the radish was, and they do a lot of things there, and we see lots of multiplication of earthworms from planting radishes. We also see lower cyst nematode count, and we also are seeing lower slug counts where we have grown radishes prior to having corn. This is at planting time. This is April the 28th. The soil here was about 52 degrees where the radish row was, and it was like 47 degrees where the pea row was. So we tried to plant pretty close to our radish row. As you can see, there's still some holes there in the soil, but as the disc blade and the fluted clover runs beside there, it fills those holes back up, and we have not had any problems with the corn being too deep because it fell in a radish hole. Again, here's the corn. We was planting the 24th, 25th of April, and this is the May the 12th, so this will be about 2 weeks old, and you can see the corn emerging real well, and you can also see part of the radish still there. This is a later picture in June, and here you can see where we just barely missed the radish row with the corn row, but it looks like the radishes actually lift the soil 4 to 5 inches, so it acts like a strip till machine, and we're really pleased with what we're seeing. This is the nutrients from the radishes that we took. This is a representative of 90 samples off of 125 acres, and a summary of those 90 samples, and this was the average of those 90 samples. And what this says is that we found in May the 1st, we had 120 pounds or 150 pounds of nitrogen available to the new corn crop, 23 pounds of phosphorus being stored in the radish, 230 pounds of potash, some sulfur and some calcium and some manganese. So these radishes are pulling up nutrients from the subsoil and storing them closer to the surface where our corn roots can use them. We also did a lot of work with soil densities, and here we are checking the density of the soil in the compaction layer. You can see the root of the radish. That picture is about 20 inches deep to the root, and I got tired of digging to find it any further. Our soil compaction study was done on the same 90 samples, and this is an average. The first bar graph is the oilseed radish with winter peas beside them. And if you go down there at about the 15-inch level or close to it, or the 10-inch level, you can see it only took about, at the 10-inch level, it took 60 pounds of pressure to push a probe in the ground where we had radishes and peas. And in the strictly no-till corn and bean rotation, it took 150 pounds. So these radishes are loose in the soil, and even if we went down to 22 inches deep, it only took 150 pounds of pressure where the radishes were, but it took about 300 where we had just corn and beans. So they are really doing the job for us to lift the soil and loosen the soil and fracture it. This was our soil density study we did, and here we're showing our mixes. The mix happens to be the radish and the peas together. Our soil density was 1.5. Winter peas by themselves was about 1.52, and just strictly daikon or tillage radishes by themselves, it didn't loosen the soil very much from regular, just being regular no-till, which is about 1.6. So the mixes really are doing a lot of good for us to improve the soil and improve the density in the soil. The benefit to covers, we've talked about it, supplies nitrogen, improves soil tilth and water infiltration, reduces disease and also nematodes, helps control the weeds, and it traps nutrients and keeps them from leaching through the soil profile. We're using a SPAD meter to know how much nitrogen our corn crop will grow, because I still have to be profitable even though we use cover crops. We found that on our farm, our SPAD meter had to read 42 parts per million to make 200 bushel corn. Here you can see, even after ear fill, you can see the ear back there with the brown husk on it. We still had 52 parts per million. This corn had 20 pounds of nitrogen applied to it at planting time, and that was all. This was corn where we had hairy vetch and on our hilltop, not quite as good as where we had peas and radishes, but we still had ample nitrogen to produce a corn crop. And this one was one where we had rye and some crimson clover, and this just helped prove the fact that our clovers are not producing as much nitrogen as some of our winter annuals will do, and we should have added some nitrogen to this plot to enhance the yield. This is a summary of our yields from 1983 to 2010. And the blue column is where we've been putting full amounts of nitrogen on when we have covers till you get down to the yellow bar. And the yellow bar is a representative where we did not have any cover, because we knew that the cover crops were supplying nitrogen, but we didn't know how much nitrogen was just in the corn and bean rotation. So, and you can see if we reduced it by 80 pounds, we didn't increase the yield very much. And if we reduced it by 135 pounds, we still stayed the same. And, you know, in 2010, we grew 230 bushel with 50 pounds of nitrogen for the growing season. Just a little bit about our vegetable crop. We have about 12 acres of vegetables. We grow 6 acres of pumpkins, about 4 acres of sweet corn, and about 2 acres of peas and green beans and tomatoes, and the rest of the A through Z commodities. This happened to be where we planted all our tomatoes, and we planted rye here. my wife needed a new couch, so I had to buy her a new couch, and I couldn't afford to buy a crimper roller, so we used an old cultipacker that we had. And here we're just rolling down the rye. It was in head. You can see it there. It was cold. This was May the 6th. And then after we rolled the rye, we planted our tomatoes. We put a drip irrigation line in, and we also use square tomato cages to hold them upright. The drip line was only used one time during the year where the rye was. And this is just a shot of the tomatoes later on. This is a month later. You can see how well they've grown. There's no weeds. And we had the same amount of tomatoes conventional here, and these tomatoes produced a half a bushel more tomatoes than where we had them conventional. And where we used conventional drip lines, we had to use drip line and water every week during the growing season. I guess that kind of summarizes what we've done. And Dave, I'll try to answer any questions that the group has.
Well, thank you, Dave. That was a whirlwind expose on the use of cover crops, and I think operator, if you want to open the line up for anybody who wants to ask a question by hitting *1 and giving your name, and she'll do that. But in the meantime, a couple questions came in during your presentation. One, again, what time of the year do you need to plant your radish seed to get the maximum benefits that you're describing in your operation? And can you talk a little bit about anything unique that you've done to ensure that you get success?
Okay, Dave. I think, as a whole, we need to get the maximum size. If you saw you're probably seeing that great big one you see there. That radish is about 12 to 14 weeks old. So that would be putting it in after wheat harvest, probably the last week of July, first week of August. I really don't know whether they need to be that big. I would prefer they was only 1.5 inches or 2 inches in diameter instead of 4. So my recommendation is if you have can plant radishes and you have 6 weeks before you have a killing freeze, they should accomplish what we're after and return double the amount of return versus the cost of the radish to put out per acre. With our precision planting, we're using about 1.5 pounds or 2 pounds per acre. If we use a drill and use a blend with the peas and the radishes, I think they ought to be put on about 3.5 or 4 pounds. I think if you get them thicker than 4 pounds, you don't have the opportunity to get the large tuber that you need, and it won't go as deep. I still feel that if we have 5 or 6 weeks before a killing freeze, they'll return us as good an investment as we can get, Dave.
Your seeding rates be a little thinner than what a standard NRCS rate would be?
That's correct. Mainly because, I'm trying to make some money and save some money. And I think as we've done the research on it, I think the recommendations that I'm giving you seems to be to receive the most ample benefit from the amount of seed we can use. If we use more seed than that, we don't see increase in benefit, Dave.
Okay. Well, that's what I was hoping you'd say that. So I got a question about the use of your herbicides. You kind of were going, sounds like back and forth. You use some, now you don't. Can you maybe explain where you're at as far as the use of herbicides, where you were and where you are in 2011 this year?
Well, we've came from the gamut of applying 3 to 4 herbicides, both corn and bean wise, to applying one time in our soybean crop where we're using rye. Only about 80% of our soybeans are in rye presently, mainly because we just can't get it all done. And where we have the rye, we use one shot of Roundup after planting, and the rye seems to suppress all the problems that we have. If we're in a corn-bean rotation, we're still using at least 2 trips and maybe 3 to control the weed species. In our corn, with our cover crops, we're down to half rates of herbicide as far as residual goes, and a third of the rate of the Roundup.
Do you ever foresee a time when you're not going to be to the point where you wouldn't have to use any herbicides, Dave?
Well, presently we're trying to relearn our covers. Dave, you and Ray Archuleta and some of the fellows in North Dakota have been working with 8s and 10-way blends, and we happen to have a lot of those 8s and 10-way blends planted presently, and I am hoping with the addition to them in our operation that we can be sustainable enough that we will not have to use nutrients or chemicals to grow corn or beans. But that we're still in the planning stage of that one.
Okay. And then maybe last question related to herbicides. I had a question about organic farming, and the question is, what do you think you could use your cover crops, or what cover crops would be best utilized in an organic system where herbicides are an option, and what would you recommend starting with? You know, what would be the easiest cover crop to start into a system with, and where in a rotation like you're running that might be?
Well, I guess if I was looking strictly at organics and how I could get started, I'd look at using probably some cereal rye, probably mix that with either radishes or winter peas, depending on what he was going to do with the rye. If he was going to soybeans, I would probably put some radishes with it, and I'd probably try to figure out how to get 30 to 50 pounds of nitrogen. And if it's organic, that would have to be some sort of manure or something like that to go along with that. And if he was going to go to corn, I would probably look at low rates of rye with high rates of winter peas, and probably a pound or pound and a half of radishes to loosen the soil, Dave.
Okay. Now, you seem to not like a heavy rye cover. I noted that you said thin rye because it's too thick and your ground doesn't warm up as much.
That's correct. You know, my seeding rates are probably lower than anybody that you'll hear recommend, and I know we need to stay with what NRCS recommends, but I think you need to try to keep that on the low end of what their recommendations are. You know, we started out in the 78s with 2 and 3 bushel of rye like the university told us to do. It was really thick. It really suppressed the weeds, but we couldn't get any sunlight or we couldn't get any air down through it, and we had to let that rye grow and mature in order to get the ground dry. And then we found as we reduced the rates down to about a bushel or down to about, if you're using a drill or a planter, down to 30 or 25 pounds, the air gets around it, and the crop you're planting into it just does so much better because it can get sunlight quicker.
Yeah, well, I think our seeding rates we didn't adjust them. We were still trying to raise, 60 bushel wheat or whatever rye.
Right.
And didn't
and we're not using a cover crop as a crop that you're going to harvest. See, and I think all the recommendations up till the last year or two has been for producing seeds and not to produce a cover.
Okay. Let me, operator, do we have any calls come in?
Yes, sir. You have 2 questions. One moment. Jim from Georgia, you may ask your question.
David, this is Jim Dangler from Georgia. What I'm going to ask you is could be kind of indirectly a plug for Ohio tourism, but you didn't mention the bass fishing and trout fishing that you do.
We don't fish very much, mainly because there's only 2 of us in our operation, my wife and I, and when you're growing produce, you don't have much time to do that, but we do have tremendous places to fish for bass, and a lot of farm plants have got bluegill, and they're 3 or 4 pounds, and they're fun to catch. Ohio's a good place to come, and if you ever get there, feel free to look us up, and we'll show you around. We'll take time to show you what we're doing.
Right. Well, the reason why I asked, and David Lamm can attest to this because he knows the people I'm talking about, we have a few people who really promote conservation tillage, and they talk about all the free time they have after they plant. Their neighbors are out there sweating and spending money on things they don't need to.
Well,
so you're busy, but how about your neighbors? Do they see you out fishing or picking vegetables while they're working?
They see us picking vegetables. You know, our 15 acres of produce equals the return of 200 acres of corn. The only problem is the 200 acres of corn only takes 2 or 3 days, and the produce takes a whole year because it takes a whole lot more effort. There is a chance to receive a lot more cash that sometimes gets lost in the operation, and no one seems to understand where it went, you know, when you sell produce.
Okay. All right, so are your neighbors catching on to this, what you're doing?
Yeah, some of our neighbors are catching on, right. Yes.
Just like I said at the beginning, his field day, he had 130 or 40 producers from as far away as southern Kentucky and northern Ohio, and I'm not sure how far east and west. So, operator, you say we had another question? Thanks for your question, Jim. On the phone there?
Yes. John Lee, you may ask your question.
Thank you. First of all, that's a really good presentation that you gave, and I had a couple of questions that I wanted to ask. The first question, for a farmer who is trying to convert over to no-till using cover crops, you mentioned something that kind of stood out, and I've seen this with some farmers who were raising rye, and they were using no-till planters and had a difficult time getting the planter to plant the corn crop deep enough into the soil and then also close it back up. And I know you've conditioned your soil now, so you probably don't have that problem, but when you first started to convert to no-till, did you have any problems with your equipment trying to plant into the residue?
Yes, we did, and I think the biggest problem we had with our equipment was we were thinking that we needed so much weight to get through that green residue, and what was going on was we put so much weight on our planter units that it was actually lifting the frame of the planter, which meant the planter wouldn't go in the ground, you know. And I've worked on a lot of planters that guys cannot get to go in the ground, and if you loosen up some of the down pressure springs, that will help the planter to run in. It's like the old theory of the frog or the nose on the plow point. If it wears off, the plow keeps getting shallower.
Right.
You know? And you need to make that planter suck in the ground just like it does with the plow point, you know.
Okay.
And, by loosening up the spring tension, we found the frame was where it belonged. It takes a little more fine-tuning of the planter to get it to work in these covers till you get the soil loose enough. And in about 3 years, you can take all the weight off the planter because you don't need to worry about it going in the ground. The soil is loose enough that it'll just do a nice job.
The last question is the Sunn hemp. I've seen a lot of promise with the Sunn hemp. I've also heard people talk about the difficulty in trying to find the seed and the cost for the seed. Do you mind sharing with us how easy it is for you to acquire that seed, maybe where you're getting it and how much it costs per pound to buy that seed? And I'd also be interested in how many pounds per acre are you planting?
Well, the real problem is finding the cover crops, and if you know that seems to be loosening up a lot in a lot of areas because now more people are using them. You know, a good seed dealer should be able to get the cover crops you need. Your seed dealer needs to make sure that he understands that if you're using different legumes, you need to use the right inoculation. And, you know, Sunn hemp takes a whole different inoculation than winter peas do, just like cowpeas takes a different inoculation than winter peas. So there's 3 different forms of inoculation there, and if you go to your seed dealer and ask him if he knows what inoculation he needs, and if he tells you you don't need any, I would suggest you go somewhere else and buy the cover crops. The cost of the Sunn hemp is about $4 a pound. mainly because it's not been used for cover very much, and it's hard to come by. As we adopt these cover crops and get more of them being produced, they will get cheaper. For an example, when we started with hairy vetch, it was $5 and $6 a pound, and today you can buy vetch for about $2 a pound from anywhere, because the demand is, they're producing more seeds for us.
How many pounds per acre do you plant sun hemp when you're planting it?
We're using about 7 to 8 pounds of sun hemp per acre.
So you're putting roughly $28 an acre into planting the sun hemp?
Correct.
Okay.
Correct.
Thank you.
Yeah, John, and I'll pass that on to Ramona, our plant material specialist. I know there's she might have a list of sources for sun hemp seed that we can try and get out to folks. Next question, Dave. I know you got some time left here. Is that the question is, do you have or have you ever considered using a pre-side dress nitrate test to determine whether you need additional nitrogen, or is that how you're using your SPAD meter at that time of the year when you'd be able to make that decision, whereas your pictures kind of showed it was kind of late in the game to be thinking about it?
Right. I guess we use our SPAD meter when the corn's 18 to 20 inches tall. That would be the time we'd be side dressing. And that's, if it's over 45 parts per million, it doesn't get any side dress. If it's 42, we'll add some. If it's 30, we'll add a whole lot more. And we've done that because we've done some trials and know where that SPAD meter needs to read. We also send some soil in early in the spring to just do nitrate tests to see how much the cover crops put in the soil or in the soil presently, and that usually happens the first 2 weeks in April. Then we also, in the field, if you don't have the luxury of having these things, and we didn't have that luxury for about 15 years, we always left a certain percent of the corn without nitrogen. And when I say a certain percent, I was always greedy and wanted a good yield, so probably only left 12 rows or 24 rows or whatever the row width of my header was 3 or 4 times. With no nitrogen in the field, then the half-rate nitrogen part of the field, and then the balance of the field always got the nitrogen it needed because I thought I wanted to be as good as everybody else. And then when we shelled the corn in the fall, we found out that on hindsight that we didn't need to use any nitrogen at all in a lot of cases, But I had a lot better peace of mind knowing it was out there.
Yeah, you sleep a little. Well, have you adjusted your rates down? I mean, over the last 4 or 5 years, have you noticed? I mean, if you're cutting out nitrogen, that means you're putting more money in your pocket. Has that been what you found, or?
Yes. Our cover crops, when we procedurally plant them, they're costing us about $17.80 to $18.80 an acre to put them in, and we're being able to grow and store 200 units of nitrogen for our corn crops, so we can put 10 or 15 pounds of nitrogen on at planting time because the seedling needs some N right there to get it to grow and stay green. After it's out of the ground and 4 or 5 inches tall, we can start using the nitrogen that's tied up in the soil profile, and that corn just keeps on growing. And that seems to be our best policy.
You haven't said anything about P and K. Are you just putting on the standard with the planter, your P and K, or?
Well, the last 4 years we've not used any P and K because our soil readings are gradually improving without adding any extra other than just what's in the row starter, and our row starter is normally a liquid of a 924-3 at about 4 or 5 gallons the acre. But we've seen our cover crops seem to be pulling up nutrients from our subsoil and putting it close to the surface so our corn and bean plants can utilize them. And our soil samples every other year show us gaining phosphorus and potash rather than losing it.
Have you found, there's another question, have you found that you said you did a pre-plant nitrate test. Have you found that the nitrogen showing up is about what was being predicted? You see these tables that the universities put out for, hairy vetch or, to give you that range? Has it been within that range? Has it been higher or lower? Have you even seen those tables that generated?
The table that Ohio State uses, or that has showed me, we seem to be about 5 or 10% higher than their tables are showing, Dave, on that. And we seem to be able to keep the nitrogen in the profile with these deep-rooted plants that we're using for a little longer than they say we should be able to, But we're talking about nodulations as big as your thumbnail, and it takes a while for that bacteria. If it's 5 inches deep in the soil, it takes that soil a month and a half or 2 months to warm up enough to get the bacteria to eat that. So it becomes released when the corn's probably 2.5 or 3 foot tall, just when it's deciding how big the ear is going to be and how many rows of kernels it's going to have. And then later on in the season, we have more breakdown that influence test weight and standability.
Yeah. So that's one thing I noticed, Dave. People work awful hard to put fertilizer where those natural nodulation is occurring. I don't know how you can improve on that step. Another question here is, what are the rates of are you using a Roundup or 2,4-D when you're killing your hairy vetch, and have you found that you could modify those, cut them back somewhat?
Where we have straight hairy vetch without any volunteer wheat, we're using a half a pint of 2,4-D only, because the 2,4-D will take it out. With our new planter, the way the press wheels are set up, we don't even need to use 2,4-D. When the press wheels run over the hairy vetch, it'll turn it brown and it dies because it mashes it. If we have volunteer wheat, we'll put a pint of Roundup with the 2,4-D, and that'll take out the wheat for us. You're
able to get enough of a crimping action like you would see with like a Rodell type of crimper with your planter set up on the 15-inch rows?
Right, because our rubber tires on our planter is 3.5 inches wide. We only have about 2 inches that don't get run over with a rubber press wheel or a wheel from the planter or a wheel from a tractor,
Yeah, I hadn't really thought about that. That's pretty impressive. Another question again is, when you're judging terminating your crop in the spring, do you have a magical height that you look at before you decide to terminate it or spray it?
Not really, Dave. I guess the magical number is when can I get it planted. We attempt to listen to the weather forecaster and believe him about half the time. We may terminate early if it's been really dry for 2 weeks and we're still a week or two away from planting. But if it's dry and it would be the 1st of April, we'll probably be planting corn, so we'll terminate it when we plant the corn or the beans. It would also have to be awful dry for me to terminate a plant in March, because there's still 4 weeks before we really get going on planting. And the problem you have with terminating any cover crop before planting, it becomes a cover that will not allow the sunlight or the air to get down to help dry out the soil.
You guys would have had a problem this spring with that, wouldn't you?
Yes, and that was the reason we fought so diligently with the crop insurance, and or talked to them, not fought with them, but talked to them, and they were willing to keep moving the date of terminating these crops to correspond better with our covers. And I think that was a remarkable thing to get accomplished when you can get the federal government to move as fast as they did on those dates.
Yeah, that was quite impressive. Can you restate your seeding rates again for your radish and your peas?
Now, on precision planting, we're using a pound to a pound and a half of radishes and 18 to 20 pounds of peas. If you're using a drill or an air seeder, you're probably going to be somewhere between 2 and 3 pounds of radishes and probably 22 to 28 pounds of peas.
Have you had much trouble with that when you use a drill, of the mixing, keeping it from being separated, or does that seem to be an issue?
That doesn't seem to be an issue with those, because the radishes are a lot smaller, but they seem to flow really well through the drill,
Operator, do we have any more questions called in?
Yes, sir. We have one more question. One moment. Mr. McClure, you may ask your question.
Dave, you've had some very simple mixes, and I know out west they use a lot more cocktail mixes where they've got 8 or 10 different species in there. What's your feelings on that, and have you given any field trials on your farm in Ohio?
Yes. This year this is our first attempt for that. My thought pattern on that was that when I talked to those like Jay Fuhrer and those people out there that's doing that, and they can tell me that they are sustainable enough that they do not need to buy manufactured fertilizer. That sparked my interest. So this year we have 3 plots out. We have 3 farms. The first farm is 40 years of no-till, and it has 5 different plots from a 5-way to a 10-way. They're all 200-foot wide, the width of the farm, the field. And what we're going to do there is we're going to plant corn the opposite direction. We're going to adjust the fertilizer rate from 0 to half rates to full rates and repeat that 3 or 4 times. And we hope our plot's large enough that the yield monitor is going to respond on these 5 or 6 different mixes that we have. And we should be able to determine by next fall which mix is working the best for Ohio. We have repeated that same plot in a 5-year no-till field, and we've done it in a first-year no-till field, the same plots, and the same kind of directions are going to be used. We're presently taking soil samples to send to a soils lab that can give us the microbes and everything else that's underneath the soil, so we have a baseline to start with, and we can see how fast we can improve the soil life. So we will have some information on that.
Are you doing a soil food web analysis, Dave?
We're doing the soil food web analysis. My biggest concern and problems we had was when you put 10 or 5 or 10 or 6 or 8 species in a drill, the drill only plants one of them right, and how do you set it so you can get the right amount on? And it was just an educated guess to get that accomplished this year. I'm hoping we'll have a better handle on that as we keep trying to learn more how to do that.
Okay, thank you. Any more questions by the phone, operator?
We have no further phone questions, sir.
Okay. Well, listen, Dave, I know you've got a farmer's market to get to, and I just want to let you know I appreciate your participation, and I'm going to let you go. And I just want to remind folks that, again, if this is going to be recorded or has been recorded, replay will be available at the site that I just showed you at the Science and Technology Training Library, and you'll find, I think there's over 80 or 90 different webinars. So there's a lot of good training information out there. Make sure you send your CCA sheets to Holly Kirkendall here at the East Tech Center within the next couple of days. Keep her happy and keep us happy around here. And with that, Dave, I think I looked up there. We had 170 attendees at one point. That's the biggest of all. So that tells me that we had PhDs and NRCS, but we like to listen to a good farmer talk about his operation, and I think we heard an excellent presentation today. And if I was there to shake your hand, I would. And one thing I'm going to do, Dave Brandt's going to have a field day next September, right, Dave?
That's correct.
And now he won't pay your way to attend, but I would think everybody would be well advised to participate that, and we'll make sure to get information out on that because you'll be able to see some of these cover crops that he's showing these slides of in action up and growing. So with that, I appreciate everybody's attending, and Dave, I appreciate your help with this. And we'll just let everybody go. And, Dave, you can go help your wife get to the farmer's market.
All right. Thank you, Dave.
Okay. Have a good day, everybody.
Okay.
Thank you for your participation. Your call has concluded. You may disconnect at this time.